Good afternoon, grade 11th. So, couldn't be there today, so I thought I'd prep this video for you so we could take a look at 7.6. We are getting right near the end of chapter 7. So, be with me please, have your books open to section 7.6, and let's take a look at this. So far we've looked at quadratic functions that have been in this expanded form, y equals ax squared plus bx plus c. We often call that general form. And we've also looked at this factored form, and remember that allowed us to find the x-intercepts equal to r and s. There's a third form, and we're going to look at that vertex form of the equation. I'd like you to highlight this here. Y is equal to a, the same a as in every other one, times x minus p squared plus q, and it's useful because p comma q is going to be our vertex. So I'm going to switch over to the next page. On here, you're going to go over to the back side, and we're going to look at y is equal to 2 times x minus 3 squared plus 4. So we're looking at a couple of different parts of this, and the first part that we'll take a look at is the a value. So in this case, our a value is 2. That means a is greater than 0, so the parabola opens up. The 2 also means that it's going to be vertically expanded. It's going to get stretched a little bit. Our vertex is given by whatever comes after the negative sign, so in this case the 3, and whatever comes after the plus, so the 4. So our vertex is at 3, 4. Something else that we've talked about is our axis of symmetry. And we've seen before that the axis of symmetry is the same as the x-coordinate of the vertex. So our axis of symmetry is going to be x is equal to 3. To find the y-intercept, we know that the x-coordinate is going to be 0. So we just take this equation, and we have y is equal to 2. We replace the x with a 0, minus 3 squared plus 4, and we solve for y. The next thing is our x-intercept. Well, the x-intercept in this case is since the vertex is above the x-axis, we went over 3 and up 4, and it opens up, the graph doesn't cross the x-axis. So there are no x-intercepts. We could say that it's not applicable. And finally, we'll look at domain and range. Domain. A reminder that the domain is x values, all the x values, such that x is an element of the set of real numbers. And the range is all the possible y values for this parabola. We say all the y's such that y is, in this case, because it opens up, it's going to be the y's that are greater than or equal to the y-coordinate of the vertex. So y is going to be greater than or equal to 4, and y is an element also of the set of real numbers. So that's a lot of information that you can get just by looking at the equation. So let's do something like this. We know our vertex is at 3, 4, and it opens up. So my vertex, I'm going to plot that. That's over 3 and up 4. There we go. So I'm just going to plot a point here called 3, 4. Okay, I'm not paying attention to the grid lines here. I'm just putting a dot in. So 3, 4. And it opens up, and it crosses the y-axis at 22. So I'm just going to make a point here called that 0, 22. That's my y-intercept. And my parabola is going to come up through point and symmetrical on the other side. So if I did about this much space, somewhere about here and here, I have another point. And I know what to call that because this was in the middle at 3. My y-intercept is at 0. So this is going to be at 6, 22. And I could find the coordinate of any other point that I wanted. If I wanted to find out what the coordinate was at when x is 1, or when x was 5, let's say over here somewhere, I could say y is equal to 2 times 5 minus 3 squared plus 4. I just replaced the x with 5. 5 minus 3 is 2, so that gives me y equals 2 times 2 squared plus 4. 2 squared is 4. 2 times 4 is 8, so that gives me y equals 8 plus 4, and y equals 12. So when x is 5, y is 12, so I've got a point right here at 5, 12. Okay, that means this point must be at 1, 12. Maybe you want to watch that again so that you can complete your notes. And whoever your teacher is can rewind this if you feel it's appropriate. Now this time you'll notice that there's no number after the bracket squared. Well, that must be because it's like saying plus 0. So, if we follow the same format as before, our a value is equal to -1. That means a is less than 0, and the parabola opens the vertex. Remember that the vertex is, I was thinking ahead to the p, the vertex is some point p comma q. So in this case, that vertex is equal to, so my p value is -1, and my q value, which is over here, is 0. The axis of symmetry goes through the x-coordinate of the vertex. So we can say that x equals -1. That's our axis of symmetry. Our y-intercept is what happens when x is equal to 0. So I get y is equal to -0 plus 1, which is just 1 squared, plus 0, which doesn't do anything. 1 squared is 1, and negative of the opposite of 1 is -1. So my y-intercept is y equals -1. Our domain, like we said before, and this is going to be true for all parabolas, is going to be that x is an element of the set of real numbers. And our range, in this case, because it opens down, is going to be all the y's, such that y is less than or equal to the y-coordinate of the vertex, which is 0. And y is an element of the set of real numbers. So with that, we can graph our parabola. This time our vertex was at -1, 0. That's right on the x-axis. And it's opening down, so I don't really need the upper part of my parabola. I've got a point here. This time I will plot it right on the grid at -1, 0. We have a y-intercept at -1. That means symmetrically there's another point over here. And if I wanted to find out what happened when x is 1, or when x is 2, let's find out what happens when x is 2. So I could go y is equal to -2 plus 1 squared. 2 plus 1 is 3. 3 squared is 9. So y equals -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And if this is my axis of symmetry, at x equals -1, symmetrical on the other side, I get my point through all those points and get something that's quite nice and symmetrical.